The overall goal of this procedure is to detect and automate mode locking in a pre-adjusted nonlinear polarization rotation fiber laser.
This procedure provides an alternate way to existing automating procedure based on an RF spectrum analyzer, an optical spectrum analyzer, a nonlinear detecting scheme, or a pulse counting device. Its main advantages are that it is relatively inexpensive, it is easy to implement, and it requires only a small fraction of the laser output to be tapped for monitoring.
This animation shows the concept of mode locking based on nonlinear polarization rotation. The signal is polarized by the polarizer and then transformed into an elliptic polarization state by the polarization controller. The Kerr nonlinearity in the fibers of the cavity forces a rotation of this ellipse, which is proportional to the instantaneous power of the signal. Transmission at the final polarizer will thus favor the transmission of high-power portions of the signal, leading to the formation of a pulse. By positioning a polarization analyzer just before the final polarizer, detection of a pulse in the cavity is possible by discriminating between polarization states. This is achievable because a pulse will undergo a larger nonlinear polarization rotation than a continuous wave signal during a round trip in the cavity. The first step is to set up a fiber laser system on a stable platform. To begin, set up the laser ring cavity at the core of this experiment on an optical bench. This schematic provides an overview for